Okay, so we should talk about we can run a command decided by ourselves and send it to the web program here, test.cgi, and then we can execute any command we want remotely. But not so interesting, because you know what, attackers don't just want to run one command. They want to do something like have access to a shell and run many commands, even writing a shell script program to run it remotely. Then how to do it? And I will try to reveal a secret power, a secret weapon of all attackers, their favorite weapons. We call it reverse shell. And every attackers in the world, whenever they want to run commands remotely, to be just like sitting on the local machine, and they use this technique. We call it a reverse shell. We will talk about how reverse shell works in much later lesson. I think in the week 9 we will talk in more technical detail of reverse shell, but in today we only try to run reverse shell and how to see how to create a reverse shell. So what is a reverse shell? Reverse shell is this, very simple. So we have the web server machine located remotely. So this is the web machine, and the attacker machine is here. So in the web server machine, we have the web server here. The web server, by exploiting the web server, we can run a command. So what if we run a command on the web server, we create a shell. So if we run a command and we decide to run a shell on the web server, okay, good. By running a bash shell, then we can do whatever we want if we have access to the shell. But the problem is that the attacker machine is here, so it cannot type command in the bash shell remotely, and it cannot see the output of this bash shell remotely. No, it's not possible, because the bash shell here receive the input from here. Input is a keyboard, right? Keyboard, and output of the bash shell here is a screen, local screen. So it doesn't provide any access to the attacker to the bash shell. Even the attacker can run a bash shell remotely, but it doesn't mean that the attacker can control this machine remotely. But this is where reverse shell takes place. We know that we can establish a TCP connection between the terminal of the attacker to the bash shell here remotely, and we have a TCP connection here. TCP is, if you have taken the course on computer network, then surely this is what you have already been familiar with. But for those who haven't taken this course yet, and TCP stands for Transmission Control Protocol. It helps to send data and receive data in both ways, from application to application. If we have two applications running and we want to create a communication channel between the two, then we use TCP. And the property of TCP that it can both send and receive data in both directions. Okay, so we can create a TCP connection between the attacker terminal and the bash shell. And that's the first step. First step, we try to create a TCP connection. Now the second part is that we try to redirect all the input and output of the batch shell to the TCP connection. That means the batch shell now will be the input of the batch shell, input of the batch shell will be converted to the TCP connection. That means whatever we send through the TCP connection will be provided as the input to the batch shell, and whatever the batch shell outputs, we will redirect it to the TCP connection. Okay, so by establishing a TCP connection from the attacker to the remote batch shell and redirect the input and the output of the batch shell, then we can sit on the computer attacker machine typing thing on the keyboard here. The keyboard will provide input for the TCP connection and will go all the way to the batch shell here, and whatever printed out from the batch shell go through the TCP connection to be displayed on the attacker's terminal. Okay, you see, that is very interesting, right? But how do we do it? So we need a tool which is called NC. Okay, NC stands for netcat. So we run netcat and we force it to listen to a port, like in this case 1990. So we use L, that means ask the program netcat to listen for a TCP connection to be established, and V verbose to display things out. Okay, so we run netcat. This is the like the web server here, the web machine here, and we run netcat here. Netcat will wait for a TCP connection to be established. So it listens on the port 9090. So ports of a TCP connection is just like a telephone number. So the message, the TCP connection will be established between two machines and two applications here. Each application will be specified by the IP address and the port number. So it's just like IP is like the address of your home, and the port is just like your telephone number. Okay, by combining this, then we know that who's the owner of the phone and staying at what address. So netcat program will be run in the attacker machine and try to listen for a TCP connection to be connected to port 9090. And when a TCP connection is established to netcat here, then we will see that the shell prompt appears on the attacker's machine. Then we can type any command here to run the command remotely. But how do we create a TCP connection to the netcat machine? We're gonna see here. Okay, in order to create a TCP connection to the netcat machine, okay, let's see, this is netcat. Application is listened at port 9090, but there's no connection yet. And we have another program running on the server side, which is the batch shell. Now, we have to run something on the batch shell here so that we can create a TCP connection to port 9090 of the netcat program. And also we have to redirect the inputs and outputs of the batch program to the TCP connection. Okay, so let's see, how do we do it? In the batch shell, a remote batch shell here, we run the command like this. We run the command bean bash to run a batch shell, and we use the interactive option. I stand for interactive here, interactive. That means we will see the prompt on the attacker machine. We can type command and send to bash shell. Okay, so we run it with option I stand for interactive, but it will run independently. We cannot control it yet. Now we have to redirect the outputs of the bash shell to the TCP program. So we try to redirect whatever print from the bash shell to the web server screen. We will redirect it to the TCP connection, so it will print out on the attacker's machine screen. Okay, so how do we do it? We use the greater sign here to redirect the outputs. Remember that we normally do this like this. I can do it like, for example, I can cat a.txt and I redirect the output. Instead of displaying the content of a.txt on the screen, we redirect it to b.txt. So now the content of the file b.txt will be created, and the content of b.txt is exactly what the content of a.txt is. That means we try to display it on the screen, and instead of display it on the screen, we display it to another file. So b.txt will receive the output of this command. Okay, we apply the same thing. Bin bash output. Okay, bin bash output will be redirected. This is output will be redirected to this command. And what is this command? What is interesting in Linux shell, in bash Linux shell, is that we can create a TCP connection as a device. So let's go to folder dev. Dev stands for device, and then the subfolder TCP, and then type in the IP address of the remote machine. This is the attacker IP address. So we go to the folder, a virtual folder, which is the IP address of the remote machine, I mean the attacker machine, and then a file named 9090, which is the port of the application of the remote machine. That means the netcat program. Netcat is listening in the port through the port 9090, and we can create a TCP connection by redirect our outputs to the IP address. Here is the attacker machine and the address of the application, which is netcat. Okay, so we have successfully redirect whatever printed out to the web server screen. Now we redirect it to the TCP connection. Here we redirect it to the TCP connection, and you will come at the other end at port 9090, which is the netcat program. Okay, that's for the output. Then how do we redirect the input? We still have the input to be redirected. We know that in Linux, even Windows and C program, we have three different standard file descriptor. We have here standard input. We have standard input. I'm sure in C you know this notation, right? Standard input, and it has the corresponding default file descriptor, which is 0. This is a file descriptor. 0 stand for standard input, and standard outputs will have the corresponding file descriptor 1. But we still have one more standard file, which stands for standard error. Whatever printed out when an error message appears, when we have to specify, because we have only the screen. So we also have, normally we have standard output. It's also standard standard error is also standard output, but we have the file descriptor for the standard output error is 2. So we have 3 constant. 0 stands for standard input, 1 for standard output, and 2 for standard error. We can, if we do the redirection for the first 2, that is sufficient. It's enough for us to create a remote shell. So now we redirect the input. We use this. So this is to redirect the standard input to the TCP connection. So what does this mean? We have the standard output has been redirected to the TCP connection, and it has the file descriptor 1, right? Now this is stand for standard output. So we use the value of the standard output. We specify the ampersand here, and we redirect the standard input here. Standard input is the same as the standard output, but the standard output is now the TCP connection. So this part of the command try to redirect the input as the same as the standard output, and the standard output had already been redirected to the TCP connection. So the input now is also the TCP connection, and the output is now also the TCP connection. We know that the TCP connection is the full duplex. Full duplex, that means this works in both directions at the same time. So in standard input will be redirected to this TCP connection, and output from the TCP connection too, and it works both direction, both way. Okay, good. Now till now we have redirected the standard output and standard input to the TCP connection. But if we type a command here and there is something error, if we type it incorrectly, then the error message will still be printed to the web server screen. That can alert the administrator that somebody is running something, some attacker is attacking the machine. So we also want to hide the error message. So we have to redirect the error message. That means we use this part of the command here. That means we try to redirect the standard error to the standard output. So we also have not only the output but also the error be oh sorry, I write it in the wrong direction. Here the input here, this is okay. So we both redirect the output and the error to the TCP connection. So error message and output of the batch will be displayed remotely, and input from the attacker's keyboard will be sent through the TCP connection to the batch shell. Okay, good. Now the only thing is that how to run this command remotely. It's easy because we already know that we can run it by using Shellshock attack, right? So we should use Shellshock attack to run this command remotely. Now here how it works. We use curl and try to define our customized the user agent field. We still have to specify the first pass as a function, so in order to cheat the bash shell that this whole string is a function. And then later we display our bad inputs as commands. So we echo the we define the format of the web page to be returned as just plain text and one blank line, and then we run the remote command, remote bash shell, and redirect the output to the TCP connection, the input also to the TCP connection, and the error also through the TCP connection. Okay, so this command will be run remotely on the web server, and we send all of this to the web server at this address. Okay, remember this is the web server address. This is the web server IP address, and we run this command, this program remotely. And when this command runs, it will create a TCP connection to netcast program waiting at port 9090. And then at port 9090, we will see a new prompt appears, www data at virtual machine. Okay, then we stay at this folder, and we can run whatever program here. For example, we run the program ID to display who's the actual user running this shell. Surprisingly, it's not a normal user. It is the web administrator, which has the ID 33. So the user here is www data has this priority 33, and this is not the root user. Unfortunately, we don't have the capability of taking the root user, because the Unix and Linux nowadays try to create different type of privileged user. The web server is only one user of the system, which has access to all the web folder. So if we can take, but not the other parts of the system. So if we take over, in this case, we take over the privilege of the web server administrator. So the damage we can do if we have the administrator of the web server permission is that we can change not the whole system, but we can change all the websites, and that is sufficient. If we can change the content of the website, then we can already attack all the web application running on that server. And if we can take over the website and we run bash shell here, then from this bash shell we can connect to the database, because we can steal the database password. So we can connect to the database, and then we can change things, okay, in the database. So this way we can bring down even a website, but we cannot take down the home machine, because we don't have the root user permission, but we can take down a website, which is already good, right? So this is the end of our lesson today. We have first know what is a shell, especially bash shell, and what mistake we have in the bash shell. Then we learn about how to exploit that mistake by converting an environment variable to a function. Then that is how Shellshock attack works. And we learn how to exploit the vulnerability locally. That means if we have access to the target machine, then we can exploit this. But we can also exploit this Shellshock vulnerability remotely via a web server, and we can even learn a technique. It's very powerful technique by creating a reverse shell to launch our attack remotely. We still have time, so I will try to demonstrate how you can create a reverse shell at home. Okay, so we don't have time to do everything on the class, but I will explain how you can repeat this at home. Okay, so let's see. So this is the end of our lesson. Let me show you the folder that relates to our lesson today. So you go to the shared folder, the course share folder here, public computer security, then you see all of these folders, right? Then go to lab 1, version 1, you go to lecture 3, which is Shellshock attack. So in this directory, I have already given the necessary things, which is the vulnerable program, a very short program that we exploit, right? So this is the vulnerable program that runs the ls command. If we have access to the bash shell of the victim system, then we can exploit the Shellshock attack on this program. Remember to turn this program into a setuid program and point the sh shell point to the bash shell, Shellshock bash shell. Okay. This is easy, so I leave it to you. You do it on your own. Sorry, we also have the test CGI here. I used Notepad here. So we have the test CGI program, which brings out hello world that we can run it remotely. Okay, so it's already there. All you have to do is to put this program, okay, into this folder, into the folder user libcgi bin, okay, which I already did on my machine. You see, you put the /cgi program here. So from now you can run this program by specify the IP of the web server and then the path to this program. Now what do we do next is that I have given 7 assignments here. Most of them is just repeating the task that you had already learned throughout the lesson today. That means you look at slide 3 and 4, then you try to repeat this task. Okay, so we have all this. If you reach to the end, which will be the Shellshock attack. Now I will demonstrate the Shellshock attack, and you do the previous task here all on your own. Okay, so this is the most difficult, and I run it now. In the folder, in order to help you to to don't spend much time, you don't have to spend too much time, then I have already prepared the list of all the commands you need here. So all the command you need to do throughout the lesson is already here. If you run the attacker program on another machine, then you have to specify the IP address of the victim machine. So wherever I type, I leave here XXX here, that is the IP address of the victim machine. So you replace the IP address of the victim machine into wherever I leave is XXX here, as XXX here, and wherever you see YYYY here, is the place that you have to replace it with the attacker's IP address. Okay, so which I'm gonna do it now. To create the reverse shell, I use this command. Okay, so let's find out what is the attacker IP address and what is the web server IP address. So I go to the virtual machine. Okay, I run clear. No, I run the command if config internet configuration. So you see that this command will display all the connection adapters on this virtual machine, and the IP address of this virtual machine is here. So 192, 168, 98, and 128. So this is the IP address of the web server which run here. So here we will replace the x here with the address of the web server, which is 192, 168, 192, 168, and then 98.128, right? So this is the IP address of the web server, where we can specify the path to the CGI program. Now we specify the address of the attacker's machine, so that the netcat program will wait on port 9090. Here, wait on port 9090. So I replace this with the attacker's machine IP address. I run it. Oh, it's still not working. I will run it from here. I run the bash shell from Windows. Okay, it works. So this is another machine, which is my host machine running Windows, and I'm gonna stay here as attacker machine to attack the virtual machine as a web server. Now what I run here is the netcat program, right? But before running the netcat program, I need to check what is my my IP address. If IP config. Okay, here. This is my machine, and my IP address is this 56.1. Okay, so I run the netcat program waiting on this machine. Okay, so I run netcat program LV and 9090. I run it here, but I need another Windows to launch the attack, so that it will create a TCP connection to this application, netcat application. So I run another shell, bash shell from my Windows program. I run another shell, bash. Yeah. Okay, so I put it on the left panel and here. So on this left is the netcat program. It's waiting for a TCP connection to port 9090. On another shell here, then another Windows here, I launch the attack to the web server, remote web server. Okay, so I copy the command we need to launch the attack. Okay, wait, I type it in again. 192, 168, and 56.1, right? So this is the IP address of the attacker machine, and this is the port where netcat program is waiting. So now I run this command. What does this command do? That it will run the test CGI program on the web server and exploit the Shellshock attack to run a bash shell remotely. And we redirect the output, the input, and the error message through the TCP connection to the netcat program waiting at port 9090. Okay, so I run this program. I run this command. I use curl to run it instead of using a browser, because I can customize the user agent field. Okay, so let's run it. Okay, you see the netcat program is waiting here. Now I run. Oh, why it doesn't copy? Let's wait again. There. Okay. So here we wait for a TCP connection established. here is the attack, Shellshock attack. Okay, I run it. Boop. Now, let's see what. Oh, wait. Something not working. I try to. I think one of the. Oh, okay. It's already working here. Okay, you see, it slows a bit on my machine, but we see that the TCP connection has already been received here. Received. And if we the application running, the bash shell running on the remote machine is here, and it creates a TCP connection to port 9090 of the attacker machine. Then we see that a bash prompt is already has already appeared, so we can run command remotely. Let's run ls. Okay, so what is it? Test CGI. Test CGI is the only file in the remote machine folder. Where is it? Here. You see. So this is the only file in this folder. We see that who am I? I run who am I. Okay, is the web server administrator, and I run ID. Okay, the ID of the administrator is 33. Now I try to see the password file of the web server machine, for example. Okay, I use cat etc pass. Okay, boop. There you see the list of all user there. Of course, we cannot steal the password yet because we don't have the root permission. For example, I cannot cat the shadow file. We don't have permission. Oh, sorry, cat etc shadow. So we don't have permission, so we cannot. But you can steal the password of the database at the web server by specifying the path to the ELGA web application. Remember? So this is how it works. We sit on the attacker machine, but we can control a shell. A shell is actually running on this machine, but we don't see anything appears on the victim machine because everything has already been redirected through the TCP connection. So the attacker is launching an attack and is still attacking our web server, the web server. But on the web server, the administrator doesn't know anything because things is happening in the background. Okay, so I can run like pause. Yeah, I can run the program PS. That stands for process to see which processes are running on my machine. And you see that bash Shellshock is running here. Bash Shellshock is running here. That's the attack. But this bash program is actually the shell that the remote attacker is running. Okay, so an attack is happening, but the administrator in the virtual in our web server doesn't know about it. So if you want to quit, then just type exit, then the connection is done, finished, and we can run PS again. Okay, oh sorry, it's not gone yet. Not gone yet. We should try to close the connection, but we haven't finished the bash shell. So try to repeat all of the 7 experiments at home. Yeah, okay. If you passed all of this, that means you have fully understood our lesson today. Okay, so any question can be posted to the classroom. I don't think you have any question right now, but if you have any question, go to the classroom and post them here. So I can answer to the public. That means the other friends can see the answers too. Okay. So that's the end of today's lesson. I